Chapter 2, Soldering. The following information will aid learn basic soldering schools and enable you to solder wires and electrical connectors, spice, and terminal lugs as you discussed in earlier chapters. Special skill and schooling are required of the soldering techniques of the printed circuit and boards and miniature component repair. Soldering process. Cleanliness is efficient and effective with soldering will not adhere to the dirty or greasy oxidized surface. The heat metal tend to oxidize rapidly. Reason for the oxidized scale and dirt must be removed with the chemical and mechanical means. Grease and oil films can be removed with suitable solvent. The connections are to be soldered but cleaned just prior to the actual soldering operation. Items to be soldered should be normally normally be tinned before making mechanical technician. Tinning is a coating of the material of the solder, lightly coated with the solder. When the surface has been properly cleaned and tinned, clean thin, even coating of the flux should be placed over the surface to be tinned. This will prevent oxidation while partly being heated with the soldering temperature. Rosin core soldering used preferred in the electrical work. However, the separate rosin flux must be instead. The separate rosin flux is frequently used when wires, cable, fraction, or tin. Alright, tinning and copper wire and cable. Wire should be soldered into a connector stripped so that the wire is placed in the barrel. The wire gap is approximately 132 centimeters below the end of the barrel, and the end of the insulation is done, preventing the burning of the insulation during the soldering process to allow the wire to flex easier to the stress point. Before copper wire is soldered to the connector to the end of the exposing, stripping the area of the tin holds the strands solidly together. Tinning operation satisfactory when the ends inside of the wire strands are fused together and coated with the soldered donut. Tin wires are crimped to the solder terminal and splices. Copper wires are usually tinned and dipping in the flux of view A, figure 222.5, and then in the solid bath pot, figure B of the figure, of the figure. And feel the copper wires are tinned with a soldering iron and rosin core solder. The tin over the conductor is about half its exposed length. The tin and the solder over the wire above the barrel causes the wire to be stiff, and at the point where the flexing takes place, this will result in the wire breaking. Okay, so you dip 1/8 of it deep in the rosin alcohol paste flux, and then hold the molten solder into 1/2 strip length. Sprinkle the powdered borax surface on the retarded oxidation. Step B. Dip tinning in the solder pot. Flux you with the thin copper wire with the maximum mixture of the denatured alcohol, freshly ground rosin. This type of flux must be mixed with just prior to use the pre-mixed paste flux must be used. The solder used in terminal lugs places connectors mixture of the 60% tin, 40% lead. Maintain the temperature of the soldered bath pot between 450 to 500 degrees. Keep the solder in liquid state. Skim the surface of the solder pot is necessary to metal spoon or blade. This keeps the solder clean and free of oxidizing dirt and so forth. Dip 10 wires smaller than number 8 in groups 9, 8 and 10. Dip 10 wires number 8 or larger individually sprayed. This procedure the dipping 10 is followed. Prepare the flux and solder as previously described. Make sure the exposed end of the wire is clean and free of the oil, grease, and dirt. Strands should be straight and parallel. Dirty wires should be restripped. Grass wire firmly dip at the end of the preflux into the depth of 1/8 of inch. See view A, figure 225. Remove the wire and shake off the excessive flux. Immediately dip the wire into the molten solder. Dip only half of the strip conductor length into the solder view B with the figure 225. Turn the wire slowly, solder bath until the wire is well tinned. Watch the solder fuse to the wire. Do not keep the wire in the bath longer than necessary. Remove the excessive solder by wiping the tin conductor on a cloth. Alright, warning, do not shake off excess with solder. It can cause serious burns in contact with your skin. It can also short circuits and expose electrical equipment that may be in the immediate area of the tinning operation. Caution, use only rosin core solder to the tin copper wires to be used in electrical systems. Coarse flux will cause damage during the tinning operation. Do not melt, scorch, or burn the insulation. Alternative dip tinning procedure. An electrically heated solder pot is not available. The smaller number of the wires can be tinned using the following procedure. Step A, 5/8 of an inch or larger soldering tip. Cut off the old pit tip and then drill a 3/8 of inch hole 3/8 of inch deep, filled with 60 to 40% tin lead solder. Step C. Cut off the beveled section of the tin with the discard of the soldering iron tip. Drill the hole 1/4 inch, 3/8 of inch in diameter round apart with the tip of the 2/3 through. Heat the iron, melt the rosin core solder into the hole. Tip the wires and dipping into the molten solder one at a time. Keep adding fresh rosin solder till the flux burns away. Alright, procedure for tinning copper wire with a solid soldering iron. In fields of wires that are smaller than size number 10 can be tinned with a soldering iron and rosin core solder as follows. Figure 227. The 60-40 rosin solder rosin core solder. Tinning wire with the soldering iron. Select the soldering iron with a correct heat capacity with a wire size table 2-3. Make sure that the iron is clean and well tinned. Figure 2-3 show the approximate soldering size of the tinning. American wire gauge 20 to 16, 65 watts, 14 to 12, 100 watts, and 10 to 8, 20 watts. Start holding the iron tip of the soldering together with the wire until the solder begins to flow. Move the soldering iron to the opposite side of the wire, tin half of the exposed length of the conductor. The thin surface is joined should be shaped and fitted with the then mechanically joined to make the good mechanical electrical contact. The part must be held still. Any motion that between the parts while soldering is cool usually results in poor soldering connection, commonly used as a fraction solder joint. Are your soldering tools. Many types of soldering tools are used in today. Some of the more common types of soldering is the iron and soldering gun, a resistance soldering set, the pencil iron. The following discussion will provide you with working knowledge of these tools. Alright, your soldering iron. Some of the common types of the hand soldering irons are shown in Figure 228. The high quality soldering iron operates the temperature range from 500 to 600 degrees Fahrenheit. Even with the 25 midget irons produce the temperature. The important difference for the iron side is not temperature of the thermal and air. Thermal and air is the capacity of the iron to generate the maintain satisfactory soldering temperature while giving up heat to be soldered. Although it is not practical to solder large conductors with 25 watt iron, the iron is quite suitable for the replacing half the watt resistor of the electronic circuit is soldering at the miniature connector. But one advantage of using a small iron for small work is that it's light and easy to handle and has a small tip easily used to slump close places. Even though the temperature is high enough, the midget iron does not have to have the thermal and air solder large conductors. Alright, so there's the type of the hand soldering irons. Well-designed iron, self-regulating the resistance of the elements, increase the rising of the temperature, the limit of the flow of the current. Some of the common tip shape of the soldering iron in use in the Navy are shown in Figure 229. Alright, you have your, for the 8 and larger contacts, the pyramid, and for the smaller contacts, you have the screwdriver. For the medium contacts, the chisel, wedge, and concave and bent. The iron should be tinned to the application side with the tip after the iron is heated prior to the soldering component of the circuit. After the extended use of the iron, the tip tends to become pitted due to oxidation. Pitting indicates the need of the retinning. Retinned after first filing of the tip until it has been smoothed. Alright, soldering the iron tip before and after cleaning. Before cleaning and after filing and retinning rosin core, solder 60 to 40 in tin while iron is heating the tin, soldering the iron tip, reconditioning, pitting, soldering iron tip. Your soldering gun. Figure 231 has a great popularity in the recent years, but it comes because it heats and cools rapidly and especially well adapted to maintenance troubleshooting work where only small part of the technician times especially spent actually soldering. Replaceable tip, light trigger grip, and gun. The soldering transformer in the soldering gun supplies approximately 1 volt of the high current of the loop of the copper, which acts at the soldering tip with the heat of the soldering temperature of 3 to 5 seconds. However, and it may overheat a point incandescence and left over the 30 seconds. It should avoid being because the excessive heat will burn insulating off the wire. The gun is operated with a finger switch. The gun heats only while the switch is pressed. Since the gun normally operates only for a short period of time, it's comparatively easy to keep the clean, well-tinted, short operating time, allow little oxidation to form. Because the tip is made of pure copper, it is likely to pit due to the dissolving action of solder. The gun and iron should always be kept tinned and permit proper heat transformer. The connection should be the solder tinning. It also helps to control the heat to prevent soldering buildup on the tip. The control reduces the chance of soldering spilling over the nearby component, causing short circuits. Maintaining the proper tinning of the iron and the gun, however, they made it easier with the tinning of the silver solder. The composition of silver, copper, zinc, the temperature at which the bond is formed between the copper tip and the silver solder is much higher than the lead tin solder. This tends to decrease the pitting of the action with the solder on the copper tip. Overheating small delighting wire can easily occur with the soldering gun is used for most jobs. Even a low position trigger overheats the gun after 10 seconds. When it's practiced, the heat can be controlled with the pulsing gun on and off with its trigger. The high position is used only with the fast heating of the solder heavy connections. When soldering iron or gun is used for the heating of the cooling cycle, it tends to loosen the nuts and screw with the holding and replaceable tips. When the nut on the gun becomes loose and the resistance of the tip connection increase the temperature of the connection is increased, thus reducing the heat of the tip. Continued loosening may eventually cover the open circle. Therefore, check and tighten the nuts and screws as needed. Alright, costs and soldering guns should never be used with the soldering equipment. Components such as the resistor, capacitor, transistor become the heated generator can destroy the component. They should be used only on terminals, splices, connectors, not on miniature type. or your resistance soldering set. The type of the controlled resistance soldering set, figure 232. Now used in maintenance used in many maintenance activities. That consists of the transformer supply of 3 to 6 volts and a high current stainless steel carbon tip that transforms in the turn on the foot on switch off the electrical timer. The timer can be adjusted with as long as 3 seconds soldering time. This set is especially useful for soldering cable to plugs and similar connectors, even smallest types. Figure 232 shows the resistance soldering set. In the use of double tipped probe the soldering unit adjusts the straddle of the connector cup, the connector barrel to the solder. One pulse of the current heat is for attaining the after the wire is inserted. Second pulse of the current solder to the connection that completes the job. Since the soldering tips are hot only during that brief period of actual soldering, burning of the wire, insulation melting, the connector inserts area greatly reduced. The great difficulty with the device is keeping the probe tips free of the rosin and corrosion. The cleaning block is mounted within the transformer case. For this purpose, some technicians prefer fine sandpaper for the cleaning of the double tips. Caution: do not use steel wool for cleaning tips. It's dangerous when used around electrical equipment because the strands can fall into the equipment and cause shorts of the circuits. Or your pencil iron special tips. Almost indispensable items, pencil tip soldering iron with the assortment of the tips. Figure 233 show the miniature soldering iron have the watch rating of less than 40 watts. They are easy to use and are recommended soldering small components such as miniature connectors. You have the Ungar universal handle, interchangeable tips, and threaded in units for sub-miniature soldering. Alright, one type of the pencil iron is equipped with a several different tip with the range of the 1/4 and 1/2 inch side with the diameter and various shape. The feature makes it adaptable to variable jobs. Unlike most tips held in place in the butt set screws, these tips have the threads and screws into the barrel. This feature provides excellent contact with the heating element, thus improving the heat of the transfer efficiency. Anti-seize compound generally applied with the threads tipped at each for the time installed into the tip installed with the iron. This allows the tip to be easily removed by another be inserted. A special feature for the iron soldering pot that screws the little like a tip and the hole is about the thimble with a solder, but it is useful for tinning the ends with a large number of wires. Interchangeable tips are various sizes of the shape of the specific use. That each of the extra tips can be obtained in the shape of the serve special purposes. Threading nuts useful soldering smaller items. Another advantage of the pencil soldering iron is that it can be used to improve the light source of the inspect the completed work. Simply remove the soldering tip, insert the 120 volt or 6 watt type 6S6 lamp bulb in socket. This leaves the taps and small wires are bent against the board, and terminal slot tips are provided in similar and melt the solder and straighten the leads. If not suitable tip available for the particular operation is an improvised tip that can be made with the C figure 234 rapid length with a bare copper wire around the regular tips, bend the wire into the proper shape for the purpose of this method. Also serve to reduce the thermal and air with a large iron must be used in small components. Using number 10 gauge bare copper wire, bend the tip into the desired shape. Alright, solder. Any discussion with the soldering technique should include the explanation of the solder itself. Ordinarily, soft solder is fusible or alloy consisting chiefly of the tin and lead, usually joined to more metals at the temperature below the melting point. In addition to tin and lead, softening solders occasionally contain various amounts of antimony, bismuth, cadmium, and silver. They are added to change the melting point physical properties of the alloy. Ordinary table salt has to be heated at 1,480 degrees before it melts. However, when little water is added, it dissolves easily at room temperature. The action of the molten solder melt like copper may be compared to this action of the water on salt. Solder bonds with the connection dissolve in a small amount of the copper in temperature quite and below its melting point. Thus, soldering process involves melting solvent action between the solder and the melting being joined. The solder joint is therefore chemically in nature rather than purely physical. Bond is formed with a partial chemical action, partial physical bond. The properties of the solder joint different than those of the original solder. The solder is converted to a new different alloy, though the solvent action of the two metals soldering together behave like one of the solid is unlike the two metal melts of the bolted wire and other physically attached. The types of the connection is still two pieces of metal. They are not evenly direct contact due to the insulating film of the oxide on the surface of the metal. Temperature change does not affect the solder alloy. It withstands stress and strains without the damage to the joint. Unsoldering the connection eventually becomes loose and small movements cause for the temperature variation of the gradual buildup of the oxide of the metal surface. To understand full alloy solvent action with the molten solder, look at the tin lead fusion diagram if you're on figure 235. The diagram shows the purely lead point A melts at 621 degrees. Point C shows the low melting point of the tin lead alloy. The alloy at the point C permits 63% of the tin SN63 or 37% lead. This is commonly 6337 solder. This melting point is 361 degrees Fahrenheit. This type of solder becomes very low melting point used in printed circuit boards and miniature electronic repair. As you can see, the charred melting point of the alloy is lowered to the tin and added to the lead. So the degrees in Fahrenheit, the percentage of the tin and melting point. The solder used in solder wires, electrical connectors, placement of the splices, terminal lugs, in combination 60% and 40% lead solder. The melting point is 60% tin, 40% solder is 370 degrees shown in point B. 60-40 solder is less expensive than 63-37 solder, is suitable for all general uses. Alright, the flux. As you know, the flux is a cleaning agent to remove the oxidation during soldering. They have the metal cause of the rapid oxidation. Oxidation prevents soldering with a reacting chemical with the metal. The flux of the metal with removing the oxide layer. With the operation shown in figure 236, the iron moved in the direction showing the bowling flux float away with the oxide film. The molten solder following the iron then fuses rapidly with the cleaning surface of the metal. Show the boiling flux removing the oxide film, oxide layer, clean metal, solder and solidifying movement of the iron, liquid soldering iron tip. There are two classes of flux of corrosion and corrosive and non-corrosive. Zinc chloride, hydrochloric acid, salt, aluminate are all corrosive flux. Corrosive flux should never be used with electrical or electronic repair works. Using only rosin flux and remaining the joint corrode the connection creates a defective circuit. Rosin is non-corrosive flux available to paste in liquid and powder form. Alright, and solvents. Solvents. A solvent used to clean and remove the contaminants, oil, grease, and dirt, so forth from the soldering connection. Solvents must be non-conductive, non-corrosive. Solvents must be used in a manner that keep the dissolved flux residue with a contact surface such that those in switches, parameters, connectors, ethanol, isopropyl ethanol are acceptable solvents. Warning. These cleaning solvents are highly flammable, may give off toxic vapors. Follow the Navy safety precaution. Take extreme care when using any flammable solvent. Soldering aid. Some type of the heating shunt must be used with all soldering operation. They involve the heat sensitive components. The typical heat shunt figure 237 permits soldering leave the component parts without overheating the part itself. Heating shunt must be attached carefully to prevent damage to the leads. Terminal component repairs. Component part shunts should be clipped to the lead and be between the joint and the part with the being protected. The joint is heated with the shunt absorb the excessive heat before it can be reached apart and cause damage. Alright, shows the figure 237 shows the heat shunt, 1/8 of an inch protected component soldering lug, soldering iron, copper gel sweeted into an alligator clip. Alright, small pieces of beeswax must be placed between the protected unit of the heat shunt. When the beeswax begins to melt, the temperature limit has been reached. The heat source should be removed immediately and the shunt should be left in place. Removing the shunt too soon permits the heat flow of the from the melted solder into the component. The shunt should be allowed to remain in place and cool with room temperature. Clip on the shunt is preferred because the requires positive action for removal. It does not require the technician mate to apply pressure to hold it in place. This leaves both hands-free with the solder connection. Two safety devices shown in figure 238. These devices prevents burn from the operator when the soldering iron is not used for short periods of time. Or you have a soldering iron holder and the soldering iron safety screen. Lacing conductors. Conductors with equipment that must be kept in place for the present of the new net appearance that aid in tracing of the conductors with alteration repairs and required. This is done by lacing the conductors into the wire, bundling the cable called cables. Example of lacing is shown in figure 239. When the conductors are properly laced, they support each other in a form of a neat single cable. So you have conductor lacing. A narrow flat tape should be used whenever the possible lacing or tying. The tape is not adheres to the type of the tape. The round cord must be used, but not preferred because the cord has a tendency to cut the wire insulation. Using cotton linear nylon glass fiber cord tape. According to the temperature requirements, cotton lining cord or the tape must be pre-waxed to make some moisture and the fungus resistant. Nylon cord tape must be waxed on wax. The glass fiber cord and tape that is usually not waxed. The amount of flat tape of the cord required as a single lay for the group of the conductors is about 2 and 1/2 times the length of the longest cord in the group. Twice the amount is required if the conductors are double laced. Before lacing, laying conductors on a straight parallel in each other. Do not twist them together because twisting makes the conductors lacing and wire tracing difficult during the troubleshooting. A lacing shuttle on which the cord with the wound keep the cord with the following during the lacing the operation. The shuttle, similar to the one shown in Figure 240, can easily be made with aluminum, brass, or fiber plastic scrap. Rough edge of the material used with the shuttle should be filled with a smooth to prevent the injury without operator damage to the cord. To fill the shuttle with a single fit lace, the mesh of the cord, cut it and wind it onto the shuttle. For the double lace, proceed as before, except with the double length of the cord before, but you wind on the shuttle the force of the double lace. Start both ends of the cord and tape on the shuttle in order to leave the loop for the starting of the lace. The procedure is explained later in this chapter. Our Figure 240 shows the lacing shuttle with 3 inch, 1 inch. Some equipment requires the use of the twisted wires. One example of using twisted pairs where the filament leaves certain electron tube amplifiers might minimize the radiation magnetic field. This prevents an annoying hum of the amplifier output. You should duplicate the original layout with relacing You should duplicate the original layout when relacing any wire harness. Lacing the tie bundle tight enough to prevent slipping, but not so tightly that the cord and tape cuts into the deforms insulation. But be sure especially careful when lacing or tying coaxial cable. Coaxial cable is conductor usually primary for radio frequency transmission. It consists of the center conductor separated from an outer conductor, usually called the shield, by insulating dielectric. The dielectric will maintain the constant capacitation between the two conductors, which is very important in radio transmission. The dielectric softens, deforms it easily, and tied into tightly without the wrong type of tape. Caution: do not use round cord for lacing, tying, or coaxial cable bundles that contain the coaxial cable. The usually approved military specification tape to lace and tie coaxial cables bundles containing coaxial cables. Alright, your single lace. Single lace can be started with a square knot, at least 2 marginal hitches drawn together tightly. Details are shown in the square knot. Marlin hitch is shown in Figure 241. Do not confuse the marlin hitch with a half hitch. Marlin hitch that is end pass over under the strand is shown in View A of the figure. After forming the marlin hitch, draw them tightly against the square knot is shown in View B. The lace consists of a series of marlin hitches evenly spaced 1/2 inch to 1 inch of intervals along the length of the group of the conductors shown in View C of the figure. Alright, so you have your square knot, and then the marlin hitch, and then and then you do that in View C. Alright, the lace consists of a series of marlin hitches evenly spaced 1/2 inch, 1 intervals along the length of the group of the conductors shown in View C of the figure. So when dividing conductors to form 2 or more branches, following the procedure illustrated in Figure 242, binding the conductors at least 6 turns between the 2 marlin hitches, continuing to keep the lace of the branches shown in View A. Start the new lace along the other branch. Keep the bending in place, form them the conductors before lacing. Always an extra marlin hitch. Always add an extra marlin hitch just prior to the raking out, shown in View B. Alright, so you have 6 turns starting a new lace forms bends before lacing. The extra marlin and 2 inch marlin hitches to 8 turns terminate. Double lace should be used with a group of the conductors that are 1 inch or larger in total diameter. Either the single lace or double lace may be used with a group of less than 1 inch. Double lace is applied in many manner similar with a single lace, except with the start of the telephone hitch and the double throughout the length of the lacing. The Figure 243 double and single lace may be ended by forming a loop with a separate length of the cord used and pull the lacing back and underneath the several approximately 8 turns. Figure 244. Alternate method ending of the lacing illustrated in Figure 245. Method can also be used either in single or double the cord lacing. Another method using marlin hitch or lock switch from Figure 246 to prevent slippage. This procedure will also prevent unraveling should break occur from out of the lacing. Step 1, Step 2, and then Step 3, you completed the telephone hitch. This is starting your double lace. Then you have 4 marlin hitches serving of the 8 turns, and then Step 2, and then terminate the double lace. Pulling here until the knot before finishes. Pull here until the tight before the finishing knot, final knot, and then first part of the final knot tightened. The marlin hitch is a lock switch. So the marlin hitch lock switch. Space of conductor multi-conductor cable should be laced separately with the tied and active the conductor for the cable. The few telephone hitches the 2 or more cables enter the enclosure. Each of the cable groups should be laced separately. When the groups are parallel to each other, they should be bound together with the intervals in telephone hitches. Figure 247. So you have multiple telephone hitches and spine tying cable groups. Alright, spot tying. When cable supports either the equipment is shown in Figure 248, spot ties are either discover the conductor groups that support is any more than 12 inches apart. Spot ties are made in wrapping the cord around the group that is shown in Figure 249. To finish the tie, use the clove hitch filed with a square knot with the extremely loop the free ends of the cord with the trimmed in a minimum of 3/8 of an inch using spot ties. Wrap a cord twice over the bundle and then clove hitch. Wrapping twice over the bundle and then the clove hitch, square knot. Self-clinching cable straps. Self-clinching cable straps are just lightweight, flat nylon strip. They have molded ribs and serration inside of the strip of the grip of the wire. They may be used instead of the individual cords of a tie. Securing wire groups of bundles quickly. The straps are two types of plain cable straps. One of that has a flat strip identified with the cables. Caution: do not use nylon cable straps over the wire bundles containing coaxial cables. Do not use straps in areas where failure of the strap would allow the strap to fall into the movable parts. Insulating self-clenching cable straps is done with a military standard handle tool shown in Figure 250, and illustrating working parts of the tool are shown in Figure 251. To use the tool, follow the manufacturer's instructions. Alright, 250 show the insulating self-clenching straps. In Figure 251, show the military hand tool for self-clenching cable straps. Configuration may vary. Spring return handle, tension locator optional, tension adjustment knob shape optional. Index the line. See note. Warning: use the proper tools. Make sure the strap is flush in the eye of the strap to prevent painful cuts and scratches that cover the protruding strap ends. Do not use plastic cable straps in the high temperature areas above 250 degrees. High temperature pressure sensitive tape lacing. High temperature pressure sensitive tape must be used to wire bundles in areas where the temperature exceeds 200 degrees, 50 degrees Fahrenheit. Install the tape as shown in Figure 252. Wire the tape around the wire bundles 3 times and 2/3 overlap each other. In turn, heat the sealed loose tape on the end of the side over the soldering iron tip. 3 wires, 2-3 overlap, heat seal. Screwing the wire bundles with the heat temperature areas. Warning: insulation tape, including glass fiber tape types high flammable, should be used in a high temperature environment. Only insulating tape approved with a high temperature operation suitable to continuous operation 500 degrees Fahrenheit should be used in high temperature environments. And then you have Chapter 2 summary.